Welcome to the Crazy Hat Chemist. So here we go. Equilibrium and reaction rates. Today we're doing the 9th video. Bam! Volume and pressure equilibrium shifts. So consider a closed container. Here's a can of beans. That's a closed container. So imagine if we have this closed container, we heat it up. What do you think will happen? Or if we cool it down, what do you think will happen? Okay? So, what is the relationship between pressure and volume? This is critical in answering equilibrium shifts dealing with pressure and volume. And you need to know the relationship between pressure and volume. So, this is a cutout of an engine. Hopefully you see some of the pistons are up, some of the pistons are down, and we're going to highlight a couple of those in just a second. So if the volume increases, then what happens to the pressure? So we're going to look back at that engine here, and I'm going to highlight one of the ones, the piston that is up. So that means that that volume is up. What happens to that pressure when that piston is up? What happens to the pressure? It goes down. So if the volume goes up, the pressure goes down. Hopefully that makes sense. Okay, now if the volume goes down, look at the piston right over here. This piston now is down. What happens to the pressure when the volume decreases? Okay, the pressure increases. Hopefully you see that there's an inverse relationship between volume and pressure. You should have learned that in the gas unit. If not, go back to that gas unit and get that. So here's the key feature here with an equilibrium. The shift in equilibrium will favor a volume change and therefore a mole change. So I'm going to relate that to these two volume-pressure relationships that we have written down already. So if the volume goes up, then we're going to shift the reaction to the greater number of moles of gas. Okay? And if the volume goes down, then we're going to shift the reaction to the fewest number of moles of gas. One of the key words there is it's moles, and it's of gas. It's not moles of aqueous, not moles of solid, not moles of liquid. It doesn't matter anything but moles of gas. Keep that in mind. Okay? Okay. So, note on gases and equilibrium. If an inert gas, so xenon, argon, or a gas that does not react with the reactants or products is added, this increases the total pressure of the system, and therefore there is no change, i.e. there is no shift either right or left in the equilibrium. The partial pressure of the gases in the equilibrium expression do not change, and Q, which is the reaction quotient, very similar to K, is dependent on partial pressures, which remains constant, and therefore there is no change or shift in the equilibrium. So that's why. That was the 9th video, and I'm going to go fishing. So if you like those videos, give me a thumbs up and subscribe.